Good evening, Bearcats. This is 4.7 inverse trig functions. The first thing I want you to note is that an inverse is not the same as a reciprocal. Okay. Although they're both switching or flipping or changing something, they are not the same thing. Remember, an inverse means to switch the x and the y, or the domain with the range. All right, let's take a look. All right. A couple of things that I want you to know is that that the sine function, let's just draw our basic sine function. This would be at pi over 2, pi, 3 pi over 2, and 2 pi. And it would be, parent function would be 1 to negative 1. You start at the axis, top of the amplitude, back to the axis, bottom of the amplitude, back to the axis. So your basic sine function looks like this. Our sine function does not pass the horizontal line test. And if you remember that from earlier, if it does not pass the horizontal line test, okay, then it can't have, then its inverse is not a function. So we have a little bit of a problem here. Couple of things I want to talk about is that we can restrict, I want to talk about notation and restricting our domain so that we can have an inverse function. Remember, our graph for sine also can go the other direction. So it'd be at negative pi over 2 as well. And be back down to the bottom of the amplitude. And you'll see why, and then it would go back up to the top of the amplitude, and it would continue on that way, and it would continue on this way. Alright, so if we restrict our domain of our original function, if we take just a part of this graph at the right spots, then we could create a function. Let's take a look at this. If I highlight from pi over 2 up to positive pi over 2, negative pi over 2 to positive pi over 2, then any part of that line, or that curve, let's change this really quick, any part of that curve would pass the horizontal line test and we would have a function. So our restriction is going to be from our domain restriction will be from negative pi over 2 to pi over 2. Okay, so that's our domain restriction. So if we restrict our domain of this graph just between those two values, then, or those two x values, then we would be able to have an inverse. Our inverse is denoted by a couple, two different ways. We can note it by this, so it's denoted by y equals sine, and this little negative one at the top, and that's x. So you could say, you would read that as y equals inverse sine x, or you could denote it by y equals arc sine x. Arc sine means the same as inverse sine. So both of these are kind of important. I'm going to go ahead while you're writing these down and go ahead and highlight these just to make sure that we realize how important that is right there. So that box is important, and our domain restriction is extremely important as well. Okay, let's move on. Both sine and tangent are both restricted to the same domain. So both sine or inverse, sine and tan are restricted to negative pi over 2 to pi over 2. Often I look at it this way. I draw my little axis and I think about it. It can rotate from 0 to pi over 2, and it can go from 0 to negative pi over 2. So this is both for inverse sine, which I'm going to denote with a little negative 1x, which can be read as arc sine as well, or for tan, inverse tan x, which is arc tan. So that's the restriction for sine and tan. The same is true for cosine, and we could draw the graph. Matter of fact, let's just do that. We'll do that on the next page. That'll help you look at that. So if we draw our basic cosine graph, cosine starts at 0 here, and we have negative 1, and we have our pi over 2, our pi, our 3 pi over 2, and our 2 pi. And it would go, oops, that's not negative. That's a positive 1 down to negative 1. And then cosine starts at the top of the amplitude. So we'll put our little highways in here. Starts at the top of the amplitude, then to the axis, bottom of the amplitude, to the axis, top of the amplitude. So our basic cosine graph looks something like this. If we restrict our cosine graph from 0, see, the problem is if we go backwards here, you're going to go like this, and this would not pass the horizontal line test right here. So we have to restrict from 0 going forward down to pi. So let's highlight that area and take a look at it. So if I highlight from here down to here, again, that little section of the original cosine function would pass the horizontal line test, and therefore would be have an inverse. So cosine is restricted from 0 to pi. From 0 to pi. So what I do is I draw that on my little axis, and I think of it this way. From 0 all the way to around to pi would be my inverse cosine restrictions. So cosine would have to, our arc cosine. Cosine values would have to be in the first or the second quadrant. Let's go back again. And then remember, sine and tan values would have to be in the first or the fourth quadrant. Let's work a couple of problems to kind of demonstrate this. I think this might help you a little bit and give you a couple of good examples. Okay, this would be example 1. We have arc sine 0. Uh-oh. Well, the first thing I see is it's an arc sine, so I know it's a restricted because it's an inverse, and sine is restricted to the first or the fourth quadrant. I know that this is 0, 1. I know this is 1, 0. I know this is negative 1. I'm sorry, did that backwards. 1, 0, 0, 1, and 0, negative 1. All right, so let's see what happens. What you're going to have to think, this is what you're thinking. You think, and sometimes I put my little thinking guy up here. He's got little question marks above his head. He's thinking, thinking, thinking. So you're thinking, let's see. All right, you think, where is sine 0? But only between pi or negative pi over 2 and pi over 2. So I have my little thing here, and you look, sine is, between those two, sine is 0 right here. So your answer would be, what radian measure is that? That would be 0. Now, it can't be 2 pi because you didn't go all the way around the circle twice. It can only be 0. All right, let's do another one. Example 2. Arc cosine 0. This time you're going to think, and we'll have a thinking girl. She's thinking. We're going to think, where is cosine 0, but only between 0 and pi. So you're thinking of this around here. All right, so again we have 1, 0, 0, 1, negative 1, 0. All right, cosine is 0 right here. You know that's our cosine value. And the radian measure where it's 0 is pi over 2. So cosine is 0 at pi over 2. I think we need to go Bearcats. All right, let's take another example. I have about 2 more examples and we'll be done. Let's try example 3. Arc tan of negative 1. That's not the negative for the inverse. It looks like I did that. Let's change that. I don't like that. Okay, so arc, and it's going to be tan negative 1. So we're thinking tan is 1, at pi over 4. But we don't have 1, we have negative 1. Okay, remember our little restriction for arctan or for inverse tan is going to be here or here. So remember at 45 degrees, the tan value is 1. We have the square root of 2 over 2, the square root of 2 over 2, and 1. Okay, that's at pi over 4. But we're negative 1. All right, well, negative 1 between these two quadrants would be down here in the 4th quadrant. Remember, are all surfers to California. Cosine is the only thing positive in this bottom quadrant, in the 4th quadrant. Tan would be negative. So tan would be a negative 1. And so that would be at a negative pi over 4 because we're moving from 0 clockwise, which would be a negative angle. So our arctan negative 1 would be at negative pi over 4. Negative pi over 4. All right, the last thing I want to discuss is I want to discuss compositions just a little bit, where we have, in regular compositions, you know, we have things like f of g of x or g of f of x. Well, we're going to have some things like this, except they're going to be with trig functions. So let's take a look at, let's take a look at 3 examples, and then that'll be it for tonight. We'll put them all, and this is for your compositions. The process is the same. It's just that the input's a little different, what it looks like at the beginning. So here's example, I think would be on example, what, 5? All right, example 5. So we're going to evaluate sine, arc, sine. Oops, I didn't get it all in there. Sine, arc, sine, what? Oops. There we go. All right, sine, arc, sine, 0.12. Well, we have a little bit of an issue here. What you need to know is that the inverse sine is undone by the original sine. And we saw this back when we did inverses before. So they kind of undo each other and it becomes 1. And so if they undo each other, they kind of, you can think of them as canceling each other out. They really become 1, and 1 times 0.12 would be, in fact, 0.12, and that would be your answer. So I want you to understand that property. Same would be true for arctan. Same would be true for arc cosine and cosine. All right, so now let's take a look if we don't have the same value. We don't have the same value, so let's take example 6. Let's say this time we have cosine inverse sine of 3/5. Okay, so this is like f of g of x. This is cosine of inverse sine of 3/5. So we're going to work on the inside first like we had before. We're going to draw a little axis here. We know because if it's an inverse sine, we are restricted to the first or the fourth quadrant. And because 3/5 is positive, sine can only be positive in that first quadrant because it's all surfers to California. Sine is also positive in the second quadrant, but the second quadrant doesn't fit our restriction. So we would have to be a first quadrant triangle. Draw your right triangle. Sine is opposite over hypotenuse. So from our reference angle, opposite would be 3, the hypotenuse would be 5, and of course is a 3, 4, 5 triangle. So now you have your triangle, and so you're done with all of this information. You used it to build your triangle. You used the inverse for the restriction. Then you used the 3/5 as your opposite and hypotenuse, and now we're really solving for cosine. Okay, cosine x. So cosine is adjacent over hypotenuse. So your final answer would be 4/5. 4/5. So you could say cosine x equals 4/5 is how you could say it in the end. And then really what you would do is you would say the whole thing. That cosine of inverse sine of 3/5 is equal to 4/5. All right, one last example, and you should be ready to go with your classwork tomorrow. So when you come in, I expect that you get straight busy on your work. I'm going to come by and take a look at your notes. At the end of your notes for tomorrow, I want you to, what do I want you to do? I want you to, okay, I decided what I want you to do. I want you tomorrow when you come to class, at the bottom of your notes, I want you to turn to page 343. So this is what you're going to add to your notes as soon as you walk in tomorrow before I start coming around to check. I want you to turn to page 343. I'll write this down. And there's a study tip. And I want you to read the study tip, and I want you to write that study tip on your notes. Okay, at the bottom of your notes. I want you to write study tip, page 343, and I want you to write the study tip down. It will help you quite a bit when you are evaluating these trig functions. All right, last example. This would be, I think, example 7. Example 7. Okay, so this time we're going to have sine inverse tan. Ooh, look at this. -1/2. All right. Well, we're going to go inside first. Tangent, and it's an inverse because it's tangent. We have all surfers to California because it's tangent and it's a negative. Tan could be negative. Let's see. It's positive here and here, so tan could be negative here or here. But it's an inverse tan, which we know is only restricted to this quadrant or this quadrant, so we would have to be here in the fourth quadrant. So let's build our triangle in the fourth quadrant. And tan is opposite over adjacent. Well, let's think about this. This side is the adjacent side, is the adjacent side to our theta, and it would have to be positive. The opposite side to our theta would be our negative, so that would be -1 and a +2. We would use Pythagorean theorem. That would be 4 and a 1, so that would be the square root of 5. Would be our hypotenuse side. Now we've built our triangle. We have finished with all of this information, and we were now trying to solve for sine. Okay, the whole thing's going to be equal to something in a minute. I just kind of wanted you to see that. So sine is opposite over hypotenuse, so that would be -1 over the square root of 5. So that would be -1 over the square root of 5. And as good, or I should say great, Bearcat pre-cal students, you're going to rationalize your denominator, and you're going to get a -square root of 5 over 5. And that would be your final answer. All right. Well, go Bearcats. Don't forget to write your study tip when you come in from page 343 on the bottom of your notes. I'll check that, and I'll have the assignment on the board. It's also on your calendar, and we will get busy with our inverse functions tomorrow. Have a great night.